Good afternoon, everybody. Lots of people signing on right now, so I'm going to wait a couple minutes before I start.
Hello.
Hello. Yeah, I'm thinking what happens at 1 on Monday, Wednesday is what happened when everyone first started using Netflix. It's just like the network would go down because everyone's streaming, essentially. So I'm giving people plenty of time to sign on, just knowing that like the tech might be against them. Let's take a quick look here. All right, gonna give it another minute. We're missing about 8 or 10 people at this point. While people are signing on here, I'll just kind of remind you what's coming up. So, actually, I'll just pull up the syllabus and we can all look together. All right. Okay, so it should be screen sharing the syllabus now. So if we pull down, so we are here on Monday the 14th. So today we're going to keep pushing on through our biological foundations chapter. And then we'll probably have just like a little bit of wrap up for that on Wednesday, and we'll spend some time reviewing. I actually have a Jeopardy game that we'll play for that. And then a week from today is your first exam. So on Wednesday, we'll go over it in a lot more detail, but basically it is multiple choice, matching. I think there's some true, false, and short answer. And then there's always opportunities for extra credit as well. I try to make those pretty obvious so that you can get them. The exam will be given through Blackboard, and I'm actually giving my first one Wednesday to a different class. So I already told them they're going to be my guinea pigs. So hopefully by the time I talk to you on Wednesday afternoon, I'll know what works, what doesn't, and that will really benefit you when we get to taking your exam next Monday. So make sure you are doing the reading. Make sure you are doing all your Connect stuff. I know a couple of you have contacted me about difficulties getting the book. Stay in contact with me and let me know when you get it. There are a set of quizzes, one for each chapter, that you can take in preparation for the exam. In fact, you're required to take them, get points, but they also will help you study. Yes, question. Maybe not. Maybe just someone signing on. Okay. And then you have on Wednesday, you have the Connect assignments, the interactive assignments for this chapter due. So stop share here real quick. Again, on Wednesday, we'll spend a lot more time looking at what is going to be on the exam and doing some actual review together as well. So today we'll just keep on trucking through here. Give me just a sec. For some reason, I know I actually like used it for a demonstration piece of paper. Oh, I just found it. Okay, I finally found your attendance sheet, so I'll make sure I give everybody credit for that today. I'm gonna just do a quick screenshot so that I can do it later and I don't have to sit here and stare awkwardly at you now. And then I'll double check it later in the class to make sure I didn't miss anybody. Anyone have any questions before I dive into today's lecture? Alrighty, well, it's kind of gray here. So I'm gonna turn on my side light. It's not the most flattering light, but it should mean you should be able to see me a little bit better. And oh, looks like we have something in the chat. We have another module due Wednesday. Yes, so Wednesday you have, I made the Learn Smart module for this chapter due then, so that you had a little bit of extra time, and then the assignments that are associated with it as well. Yep. And again, if you are just like having financial issues or other issues with Connect, please let me know. I know this is always a pain, so I'm very willing to work with you to try to help you get everything arranged and make sure you can get as many points as possible. Alrighty, any other questions? Awesome. Well, we are gonna dive back in. I'm gonna go ahead and screen share our PowerPoint here. Go. Alrighty. I don't know if you guys can see him from there, but Simba is here today. He's just hanging out in the chair. He came with me on the futon during my last class, and then he decided he wanted his own space. So, respect, I get it. I'm up in his grill a lot. He's used to having time by himself, so. Okay, I'm gonna pull down the chat just so I can see when you all ask questions or have comments to make. And we'll go back to talking about neurotransmitters. So if you remember, on Wednesday, we started talking about the various neurotransmitters. And just quick reminder what neurotransmitters are. So the presynaptic neuron gets the message from the previous neuron, sends it down to its axon to the axon terminal buttons, right? And between the axon terminal button of the presynaptic neuron and the dendrite of the postsynaptic neuron is the synapse. And the neurotransmitters are what transmits the message across the synapse, because we can't do it the same way we do it in the axon, or it'd be like a little electrical storm in the brain all the time. And that, as you can imagine, would be pretty bad for your brain. So we talked about dopamine and serotonin, both of which are related to feeling good, and obviously when they're off, you don't feel as good. So now we're going to start talking about norepinephrine. So norepinephrine is another one that's implicated in a lot of different mental disorders. So it controls things like your heart rate and also sleep, sexual responsiveness, stress, vigilance, and appetite. So a lot of these sort of physiological, almost primal things that are associated with not only your mental health, but also just your physical health, right? So we're talking things like circadian rhythms, the autonomic nervous system, right? Things that we don't necessarily think about, control. It helps to just make these things happen in the background. But clearly, when those get out of sync, it's a problem. So substances that affect the norepinephrine levels can include things like tricyclic antidepressants and beta blockers. Beta blockers are actually for blood pressure, So you see one of the problems that happens if these are out of balance is actually having high blood pressure. But depression is also related. Because of this relationship, beta blockers are often sometimes used as sort of an adjunct to other psychotropic medications, like an antidepressant. They might also give them a beta blocker. And this is typically if your depression is really severe, especially if it has some psychotic features. So for example, I had a client once who, when she was depressed, she heard voices telling her to put her arm in the oven and burn it. That's an example of depression with psychotic features. And clearly something like this would be helpful for that. The tricyclic antidepressants are really old school. These were like the first antidepressants developed, and in a lot of cases, these aren't actually used anymore because they have a lot of negative side effects, such as weight gain. And then the other problem with the tricyclic antidepressants is that they may be lethal in excess doses, so you can overdose them. So one of the like really cutting edge therapists in today's day and age is Marsha Linehan, who works with a lot of patients with suicidal ideation. And she has a saying, no lethal drugs for lethal patients. So she would obviously highly advocate for not prescribing these to people who had suicidal tendencies, suicidal ideation, plans to kill themselves. Another neurotransmitter is acetylcholine. So in terms of normal functioning here, it's the primary neurotransmitter used by neurons carrying messages from the CNS. The CNS, again, is the central nervous system. And it's involved in some kinds of learning and memory as well. So this is those neurons that go out to your muscles. They're going to be using acetylcholine to communicate. Now, if you have problems with imbalance in acetylcholine, certain muscular disorders, as you can imagine, if this usually helps carry messages to muscles, if this is off, then you might have some sort of muscle issues. Also, this seems to be implicated in Alzheimer's disease. So even though we've done research on it for years and years, we still haven't like perfectly figured out what causes Alzheimer's, other than knowing that it seems to be genetic, especially certain types like the early onset Alzheimer's. But this is one of the things implicated. Other things implicated include in your nerves. So think of your axons becoming like Christmas lights. If you just took them down and like put them in a box, you take them out the next year and they're this big ball. That can happen, as you can imagine. That could interfere with transmission. Other thing that seems to happen in Alzheimer's is that the support cells don't seem to do their job in sort of cleaning things up. So you get these plaques that build up, similar to plaque on your teeth. And obviously, anytime you have gunk sitting around in your brain, not necessarily going to be great, right? Substances that affect acetylcholine include nicotine. So smoking, if you're vaping and there's nicotine involved, obviously that could be part of it as well. Chewing tobacco, things along those lines. Random side note about nicotine. Nicotine addiction is actually as potent as cocaine addiction. So if you know someone who's really tried to quit smoking and really struggles, there's a legit reason why. It's very hard to actually disassociate that connection. So you might be sitting here going, why the heck is botulism toxin working here? Why is that even listed? Well, botulism toxin is Botox, okay? So people that get Botox injected in their face for cosmetic reasons. Now granted, Botox is also used for some medical conditions, but that is actually going to affect the levels of acetylcholine, right? So maybe not surprisingly, people who get a lot of Botox get it fairly frequently. They're starting to find that they have some brain issues, some memory issues, things along those lines. And it's maybe not surprising because you're injecting it into your face, your brain is right there, right? And botulism toxin is a neurotoxin. So you're injecting a neurotoxin into your brain, or into your face near your brain, And surprise, surprise, you can have problems. Again, this is nothing against anyone who does choose to use Botox. It's just not a choice I would personally make, knowing the neurobiology of it. Other things are some other substances that might be involved in medication for other things. Then there's GABA. GABA has a really long name. I never make any of my students memorize anything but GABA, okay? So the normal function of GABA is it is an inhibitory neurotransmitter in neurons of the central nervous system. So if you send GABA across the synapse, you tell the postsynaptic neuron, don't fire, don't put on this message. And problems when this is on, anxiety, right? So if you can't inhibit, thinking about things that could go horribly wrong, for example, if you can't inhibit what we call ruminate, chewing over and over and over the same thoughts when you're trying to sleep, right? That's going to be a problem. Epilepsy. So if you can't inhibit, like, your neurons just firing and firing and firing and firing, in some cases that will lead to a seizure. And seizures are terrifying, right? If you've ever seen someone who has one. In terms of substances that affect your levels of GABA, so barbiturates and tranquilizers, so things like Valium, Librium, and alcohol. So all of these are what are called depressants when we talk about things in terms of their chemical properties, especially, you know, addictive substances. So these are things that slow down your thinking, slow down your movement. So if you think about someone who's like really drunk, right? They might slur their words, they might have trouble kind of navigating space. And why people can die of alcohol poisoning is that eventually it works to slow down your brain stem, which is what tells your heart to beat, your lungs to breathe, things like that. So that's what happens when people die of alcohol poisoning, is essentially the depressant suppresses the functioning in those areas. So here you can see why some people with anxiety might self-medicate with alcohol. And it does have very similar effects to things like Valium and barbiturates, which are actually used as anti-anxiety medications. However, it's dangerous and ineffective in terms of a long-term solution, and it does lead to avoidance among other things. So just to give you an example, when I worked at the VA in 2009, 2010, there were some Vietnam vets. So if you think about Vietnam, late 60s, early 70s, right? So just think about how much time had passed. Who were just coming in for treatment for PTSD because they had been self-medicating with alcohol for years. And when they went through an alcohol treatment plan, all of a sudden the symptoms of their PTSD emerged. So, you know, it's not the best solution. It certainly can destroy, you know, your liver, your kidneys. It's not a great idea. Valium, back in the 60s, and the 50s was sometimes referred to as mother's little helper. They used to prescribe this a lot to housewives, especially educated housewives who just got bored, really, and developed anxiety and depression because of this. So a lot of women were on these medications and maybe sort of like dulling their minds at that point in time. Glutamate. So we just talked about GABA being the primary inhibitory neurotransmitter. Glutamate is the opposite. It's the primary excitatory neurotransmitter. So if glutamate goes across the synapse, it tells the postsynaptic neuron, like, fire, 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 okay? It says, go, send this message. And it's involved in learning and memory. So it's associated with brain damage after stroke. One of the things that can happen after stroke, as well as with some other neurological disorders, is that essentially your brain cells can work too much. And, you know, it's just like anyone who works too much, works out too much. You know, you hear these stories of like seemingly healthy athletes who will like have heart attacks on the field, right? Similar thing can happen with your brain cells. Your neurons work too much, they can actually die off. Substances that affect it include PCP, which used to be called angel dust. I don't really think anyone calls it that anymore. But this is a recreational dissociative drug. Once upon a time, it was used for anesthesia. We don't tend to use it for that anymore. And it gives you hallucinogenic effects and neurotoxic effects. So like, yeah, you'll have this fun, trippy experience, but just like Botox, now you're putting a neurotoxin in your body. Not the best idea, right? Okay, endorphins is probably one of the ones that you've heard the most about, right? This is one that it's kind of in sort of pop psychology. We talk about endorphins all the time. So the normal function are pleasurable sensations and also control of pain. And endorphins increase from simple things like eating chocolate, or maybe sometimes from substance use, but also from activities like exercising or engaging in sexual activity. Now, if there are imbalances in your endorphins, particularly lowered levels, that results partially from opioid addiction. So you might have seen on the news, heard about, the opioid problem in the US, pain pills being overprescribed, people getting hooked on pain pills and then going to the black market to get them, just like any other drug. These become completely problematic and can really ruin your life, to be perfectly honest. It's really horrific what opioid addiction can do to people. Pharmaceutical companies are being sued for downplaying the potential side effects of these. It's just really not good. It's also really hard to get someone off of these safely without having them have really bad side effects during these times. So, substances that affect it are the opioids. These include opium, heroin, morphine, and then methadone is actually an opioid that is used to help people step down from other opioids, particularly morphine in particular, because again, you can't just physically quit cold turkey. Your body will essentially shut down because it becomes so physically dependent on having the opioids there. Opioids are made from opium, which is a highly addictive substance made from the sap of the opium poppy. A lot of the prescribed ones are synthetic versions of that. Obviously, things like heroin and morphine, very serious addiction problems, but because of control of pain, we do still use morphine in, say, pain management situations in the hospital setting when it's very carefully monitored. If anyone's ever had a major surgery, you might have had like a button you could press that would release your morphine, right? And help you feel better when you were in a lot of pain. Interestingly, in states that have physician-assisted suicide, which they often call death with dignity, people go through a whole series of evaluations that basically says like no treatment's going to help. You're psychologically fit. You're not being coerced into doing this. And what happens is the doctor prescribes them an overdose of morphine and they go home and they take it and they pass away peacefully, usually in the presence of their family. Alrighty, so that's sort of a depressing moment to add to sort of end on talking about neurotransmitters. So let's pull back out from sort of this microscopic view of the nervous system and start to talk about the big picture here. So overall, the nervous system is your brain, your spine, and all the nerves in your body. Okay? So that is the entire nervous system. And as you can see, it's organized in a bunch of subcategories. So the central nervous system is what we've been talking the most about. That's your brain and your spinal cord. These really do the majority of the like controlling, ordering, learning, memory, processing type functions. The peripheral nervous system, though, as you can imagine, is also really important. These are the nerves that run throughout your body. They help you detect things like pain, hot, cold. They help you detect things like when you're hungry. To help you figure out when like
oh, I can't breathe, right? Maybe I need to take my inhaler if I have asthma. So these are really helpful and give the brain and the spinal cord all the messages that you need. And then also relay messages from the brain and the spinal cord to the rest of the body. So the peripheral nervous system is divided into two overarching categories. And then as you can see, there are other subcategories of those. So the autonomic nervous system communicates with the internal organs and glands. And autonomic here means that you don't have to sit there and like tell your organs what to do, right? We don't sit there and go, okay, I think I'm gonna tell my stomach to digest now, right? We don't say, okay, my heart has to beat, my heart has to beat, my heart has to beat. Or, okay, now I'm gonna take a breath, and now I'm gonna take a breath, and now I'm gonna take a breath. Now, granted, right, there are times where we purposely focus on something like our breathing, perhaps in like a meditative purpose, but we don't have to do that all the time, right? Interestingly, there are some animals that are voluntary breathers. So if you think about like sea mammals, for example, they have to control when they breathe, otherwise they would take in a bunch of water, right? But for humans, these things are automatic. So the autonomic nervous system communicates with internal organs and glands. So we don't have to be like, release the insulin to help process things, right? Our body just does it. And there are two divisions, and I think the vast majority of you did a really good job on this question to explain it to the media quiz. So looking at the sympathetic versus parasympathetic, I tried to make a cheesy joke about, is one better at telling whether you have a bad day? It didn't necessarily land, I don't think, because I was talking about being sympathetic to people. Anyway, so the sympathetic nervous system is your fight or flight. It is what kicks into gear when you need to get going, when you need to react. And again, you don't have time to go, there's a bear charging me. I wonder what I should do, right? It's just gonna kick in and get you out of there, right? So the sympathetic nervous system does things like pick up your breathing so you get more oxygen flowing throughout the body. It tends to shut down digestion in the moment because you'll need to do it. It pumps blood to your limbs, particularly your legs, because human legs tend to be stronger than our arms. They allow us to run away or maybe kick out. So in those moments, you might actually get like tingles in your fingers because the blood is being diverted. Some people will get nauseous because, again, we've just stopped digestion. Interesting thing that'll happen too is that it actually cuts some of the blood flow to the brain, not all of it, but it's sort of like, it's like, we don't need to think about this, we just need to react. So some people, when this happens, will feel dizzy either in the moment or later. And so it's all these things that, again, if we had to sit there and coordinate each one ourselves, would be very problematic, right? But our body just does it. And then the parasympathetic nervous system is what calms us back down. So it brings us back down from that high and helps us return to sort of normal levels of function. Now, what can happen in some conditions, psychological conditions, is that the coordination of these can be sort of off. So for example, someone with panic disorder might have the sympathetic nervous system kick in when there's not actually a actual life-threatening scenario. And then the parasympathetic system just isn't stepping in to calm things down. And so that's why when people have panic attacks, they experience a lot of the same symptoms that you experience when you're in an actual dangerous situation, right? Feeling dizzy, feeling nauseous, feeling tingly. And because, again, they're not like focused on saving their life, they can focus way more on what's happening. So some of these people will feel like they're dying or they're going crazy. So these people will end up in the ER thinking they've had a heart attack. Certainly you should never like assume it's a panic attack. If you think you're having a heart attack, go get checked out, right? But this can happen too. Yeah, people are sharing that they've experienced things like this, yeah. For me, you know, I feel like I should not quote, I've never had a full-blown panic attack, but I was deposed in a court case once. And it must have been my autonomic, sympathetic nervous system really kicked in that this is a really high stress situation. Because afterwards I stopped by a store to return something. And as I was standing there, it was just like, I felt like all the blood like coming back into my limbs. I felt really dizzy. I felt like I was gonna pass out. I was just soaked in sweat, right? So my sympathetic nervous system must have been kicking back in. And then I was aware of everything going on. So it was a really weird situation. But yeah, some of you may have had panic attacks before. And it's actually really normal to have one. But if it's a recurring pattern, it may be something where you want to seek psychological care for, to see a counselor or a psychologist. Okay, so that's the autonomic side. That's the side that we don't have to tell to do the things. Our brain just does it. The somatic nervous system communicates with our sense organs and our voluntary muscles. So here you have sensory and motor. So sensory are called afferent because they go back up to the brain and the spinal cord. And then motor are called efferent because it goes out from the brain to the nervous system. And now we typically think of efferent as being the motor neurons being as like, okay, we're just like controlling things like this. But they can also give signals to other parts of our body too, right? So it might even send some messages to, you know, an organ or something. For example, if we are purposely controlling our breathing, this is where we would be using the motor neurons instead of the autonomic ideas. So it's like our brain can sort of override in certain situations. So sensory, all your 5 senses, right? And we're going to go over this way more because we're going to do a whole chapter on sensation and perception. But things like sight, sound, taste, smell, touch. Touch is a huge one that we kind of underplay. But even something like our feet do so much, the nerves in our feet, in terms of navigating the space we're in, right? Helping us not to fall, things along those lines. So that's really helpful. So we get that input, and that goes back to our brain, and then we respond to it. And so sometimes this isn't going to be as obvious. So for example, right now, both my sensory and my motor neurons are firing like crazy, because I am in the process of conveying this. I see my video. That's always like a little distracting. Like I'm right here on my screen, right? So I try not to look at myself, but it's hard not to, right? And so I give myself feedback in terms of, okay, like my gestures seem to be working, these things along that. Oh, and so someone asked, how does dyspraxia affect that? That's a really good question. So there are neurological disorders that actually affect your motor conditioning. Yeah, so what can happen is, or like even your sensation of being able to recognize what motor movements you should make, for example. So yeah, these things, anytime anything goes wrong in your brain, it's gonna affect other parts of your body, right? So yeah, dyspraxia can definitely affect how you're able to navigate space, how you're able to recognize things in space and respond appropriately to them, right? And there are all kinds of disorders like this. If you're really interested in this type of thing, next fall, I'll be teaching our clinical neuropsychology class, and we talk about all the brain-based disorders, like dyspraxia, like agnosia, where you have trouble like recognizing objects or faces, and how does that make it difficult to navigate your world, right? Yeah, so anytime that you have any kind of issue going on in your brain, it's going to affect how you navigate your world in some way. Whether that's like interfering with your ability to verbally communicate, right? All of this is motor, right? There are all these different muscles in my jaw, in my tongue, right? My vocal cords, you know, all those things have to be part of this. You know, my diaphragm is working here, right? All of those things that we don't even think about as muscle coordination, right, are part of what I'm doing right now. It's a little overwhelming if we stop and think about it, and it doesn't necessarily feel voluntary, because, right, you don't feel like you have to stop and be like, now I'm going to gesture like this, right? But believe it or not, my brain is currently telling me what to do. And then sometimes like judging myself on it. I texted some of my professor friends the first week of classes, and I was like, random thoughts I have on Zoom. I feel like my thumbs look weird when I gesture Like, again, you stare at yourself enough, you're going to give yourself this weird feedback. So, in summary, a lot of information on one slide. We have one nervous system with lots of different subsections. So the central nervous system, brain and spine. Peripheral is everything else. And peripheral is the autonomic. We don't actually have to tell it what it's doing. And that's sympathetic, gear you up. Parasympathetic, calm you down. And then the somatic is looking at senses and voluntary muscles. And there is the sensory, so taking in input from the outside world. And then there's the motor, which is responding. And again, whether that's responding physically, like, oh, something's flying at my head, I better not. Or whether that's responding, someone just asked me my name, I need to get my mouth moving in order to respond, right? So all of these things come into play. All right, so another way that we communicate throughout our body is the hormone system. So these are chemical messengers in the bloodstream. And they're essentially like the non-nervous system version of neurotransmitters. It's sort of an imprecise definition, but it is a way of trying to wrap your head around it. So essentially, there are things that go through our bloodstream that tell organs or other parts of our bodies what we need to do. So the endocrine glands, there are several of these throughout our body. One is the pituitary. This is considered the master gland. This is actually in our brains. And it includes growth hormone and secrete substances influencing the operation of all the other glands. So essentially, the brain tells the pituitary, hey, tell everything else to do this. They're a good question. Do any outside factors affect hormones? Yes, definitely. Stress can affect your hormone levels. If you're on any types of medications, sometimes they can affect your hormone levels. Not necessarily a factor we think is outside, but bodily changes. So for example, if you're pregnant, it's gonna change your hormones, right? So certainly something that happened because of an outside force, and it is different to what your body typically does. So I'll give you an example. So I actually suffer from a mild thyroid disorder. So I actually have to take a medication every morning that regulates my thyroid hormones to keep my body functioning normally. Yes, very good. PCOS affects your hormones, endometriosis. There are other, if you get a cancer anywhere near any of these glands, that's going to affect your hormones, and sometimes that's due to environmental exposure. Wow, I couldn't think of the word. The other thing that can happen too is, if you are taking something related to hormones, so for example, trans individuals, as they transition, they'll be taking, say testosterone, that's going to obviously change your body. But even some other medications or substances you might be exposed to can adjust these things. Crazy example here is there's some evidence that because so many women are on birth control now, rightly so, helps us control our bodies. For some people, it just helps control symptoms of things like PCOS, for example. Because of our excrement related to that going through the water system and making its way to our rivers, lakes, oceans, etc., there's some evidence that those hormone levels are actually affecting the hormones of certain fish. Yes, chronic migraines can be affected by hormones. Yeah, if your hormone levels are off, it can affect a whole host of things, right? So that's a really good point here. The pancreas, for example, listed here, does sugar metabolism. The main thing it's working with is insulin. Clearly, that can lead to all kinds of problematic things. Diabetes is the most clear one, right? And diabetes, if it's not well regulated, is really, really scary. One of my scariest clients, I worked a lot with people with eating disorders, and was not my most underweight client, but she was a client that had type 1 diabetes, and her purging mechanism, basically, the way she tried not to gain weight was she wouldn't take her insulin as prescribed because she felt like it kept food in her body, which is technically what it does. It helps you actually process your food. So her blood sugar would get so high that it would be unreadable on her glucometer, and she would like pass out, have to go to the ER. It was sort of terrifying, right? So it's really important if you do have any kind of imbalance to get these back in check. I actually experienced prenatal diabetes, gestational diabetes while I was pregnant with my daughter, and I was able to control it with diet and exercise. I wasn't to the point where I had to use insulin or anything like that. So it can kind of, there is an example of outside forces certainly affecting these levels, right? So definitely, I think we're realizing more and more as we study modern medicine that there's a lot of things outside of us that could influence. We also are realizing more how like the mind-body connection matters, not only in like physically the neurons being connected, but also we know that like being stressed, being anxious, being depressed affects the rest of our bodies, affects the way we're able to cope with things. One of my favorite studies I've ever heard about is with their permission, they put tiny cuts on the tongues of med students, like a normal part in the semester, and then they did it during midterm or final time. And what they found is that the cuts actually took longer to heal during exam time because they were stressed and their body essentially couldn't give as much resources to do them. So it affects our physiology like that. So yes, humans are pretty complex. All these things interrelate. And I think there's probably ways we don't even realize they interrelate. Really good question. Okay, so I kind of covered the thyroid. It does your metabolic rate. So people who have really off thyroids can gain or lose weight until they are corrected. So we actually had a dog growing up. When I was growing up, who had a thyroid problem. And once we figured out what it was and we got her on thyroid medication, she lost about 1/3 of her weight, and she wasn't unhealthy. She was actually at the weight she was supposed to be, but she was carrying like 1/3 more weight because of the thyroid issue. The adrenal gland controls salt and carbohydrate metabolism. So as you can imagine, if that's off, that can lead to weight-related problems, cardiovascular-related problems. We mentioned the pancreas controls sugar metabolism by secreting insulin. And then the gonads secrete sex hormones involved in the development of secondary sex characteristics and reproduction. So the gonads are the ovaries in women and the testicles in men, or people with those features. And obviously there are people who might have both intersex individuals. And then their hormone production becomes even more complex. One thing I actually want to clear up is a lot of people think that like only men produce testosterone and only women produce other hormones. And in fact, everybody produces all of them, just in differing levels. So that's really important to note. In fact, there's just been a case of a runner from South Africa. Some of you who follow sports may have heard of this, where her body naturally secretes more testosterone. She didn't do anything to alter it. She didn't even know that it did this until she got to the Olympics and someone questioned her. And they're essentially saying they're going to disqualify her, take away her medals because of this. Again, something she can't control, something her body just did naturally. So that's a little interesting to process, right? And certainly problematic. It's hard to decide like who gets to decide what sex you are or what gender you are. All right, so here is a diagram to show you where all those things are. As I mentioned, the pituitary is in the brain. And then you have the thyroids in sort of your neck area, adrenals by the kidney, the pancreas, as I mentioned, the ovaries and the testes are your gonads. And yeah, here's the pituitary kind of zoomed in over here. So that's in your brain, and it carries messages from the brain to all the other glands that secrete hormones. It is the master gland. It says, hey, secrete these hormones that we need. And again, hormones are like neurotransmitters, but for the rest of your body. All right, so now we're going to start talking about the brain's anatomy. And so this can be somewhat complex, and also I'll try to take it pretty slow and walk you through each piece. And we'll try to highlight this in some interesting ways, talking about dysfunctions. I think kind of helps us understand how normal functioning can happen. So the brainstem and the cerebellum are back here. Okay, they are things that drive our most basic functions. Things like heart rate, breathing, digestion. So these are part of the autonomic nervous system, right? So we don't have to tell our heart to beat. And these are, again, why when you drink way too much alcohol, we're talking to people who do 21 shots in an hour on their 21st birthday. Don't do that. It's a good way to try to die. Don't do it, right? These are the people who, like, the alcohol just gets too much and this part of the brain shuts down. And that's how you can die of alcohol poisoning. Some sort of pop psychology people will call this your lizard brain, because I guess reptiles also have these same functions, but so do fish. It's a weird thing to call it. It's not like we had a lizard brain and then our human brain grew around it, right? But just sort of know you might hear that in pop psychology, people talking about these things outside of actual psych. Then there's the limbic system. So this adds emotions, complex motives, and increased memory abilities. And then most of what we tend to think of when we think of the brain is actually the cerebrum. And so it enables reasoning, planning, creating, and problem solving. And yes, cerebrum, same root where they got like cerebro in the X-Men. So I think it's more helpful, again, to see these things than to just hear the word. So here you have your brainstem, again, sort of back in through here. You have your brainstem, parts of that are the pons and the medulla, the reticular formation. Then you have the cerebellum over here. Then once we start talking about the limbic system, you have the thalamus and the hypothalamus in here. Okay, so these are things that do functions like keep us alive, but also start to think about emotions, motives, things along those like memory. So in terms of the limbic system, other important pieces, maybe one of the most important pieces, honestly, is the hippocampus. So the hippocampus is involved in establishing long-term memories, and is also involved in spatial navigation. So this is one of the first areas of the brain affected by Alzheimer's disease, which is why memory loss is one of the hallmarks of this disease. Interestingly, the hippocampus is also close to the part of your brain that processes smells. And so this is why they think that your sense of smell is one of the things most closely tied to memory. Despite the issue of the fact they're next to each other, interestingly. Okay, next is the amygdala. This is involved in memory and emotion, particularly fear and aggression, and the conditioning of these emotions. So we have to learn how to react to things beyond like basic fight or flight. I like the hippo on my campus. Thanks. So we have to learn how to, like, when do we react with what, right? And so part of it is when we genuinely experience fear, right? That's going to be, so like if you were attacked by a dog when you were a little kid, right? You might have a giant fear of dogs, whereas other people are like, why are you afraid of dogs, right? Another thing that happens though, is if you see someone you care a lot about or you respect, say when you're a kid, your parents who are afraid of certain things, you might develop that fear because you've seen them and you think, this is something I need to be afraid of, right? So that's another important part of what goes on here in the amygdala, is this association. It's also involved in modulation of memory consolidation. So it gets memories into long-term storage. And interestingly, if your emotional levels are high when you're learning something, it's more likely to be remembered easily. One of the clearest examples of this is what's called a flashbulb memory. And so this is when there is a huge traumatic event that affects a lot of the population all at once. And people remember like exactly where they were when they heard about it. So for my generation, it's September 11th. I was in college when it happened. I recall I had just, gone to our communal dorm shower, woohoo! I'd come back to my room, was checking AOL Instant Messenger, just to date myself. And a friend of mine had messaged and said, a plane hit the Twin Towers. And I remember thinking, what a horrible accident, right? Because you never immediately jump to, that was planned, right? And then walking down, seeing the second plane hit on a TV. And, I was I had a cold or a sinus infection. I was in the health clinic and they're playing it on the TV. So that whole day, is just burned in my memory. I couldn't tell you what I did on September 10th of that year. I couldn't tell you what I did on September 12th of that year. I couldn't honestly tell you what I did on September 11th of last year. But because of the emotion related to that event, I remember it. So again, that's going to make it more easily remembered. This is also why if you have a traumatic event, right, you might think that, why can't I forget this? This is why. And sometimes with traumatic events, it's actually hard to remember details, and it's sort of like your brain trying to protect you, but it's purposely sort of keeping them from you. Other parts of the limbic system here, the hypothalamus. This serves as the brain's blood testing laboratory. So it constantly monitors our blood to determine the condition of the body. So it is making sure that we are doing okay. This is going to be the check for something like, do we need to adjust those hormones levels? Do we need to tell the pituitary to do something? Does it seem like there are, things that are throwing the blood off? So it's going to respond in whatever way it can. It links the nervous system to the endocrine system through the pituitary. And it controls things like body temperature. So for example, we might get a fever when we're sick. It's part of trying to help our body fight everything off. Hunger is controlled here. Thirst, fatigue, and also circadian cycles. So when our body tells us to sleep, to wake, things along those lines. And also longer circadian cycles yearly rhythmic things. So people that, for example, get seasonal affective disorder, where they get depressed in the winter. It's actually related to the circadian rhythm and the fact that in the winter there's traditionally less light available. All right, so now we're going to talk in more detail about the cerebrum. And again, when we picture a brain, we're typically picturing the cerebrum. So it's the topmost layer of the brain. It's the bulbous cap. Again, what we think of when we think brains, when we see in zombie Halloween decorations, right? Is the cerebrum. And so it includes the cerebral cortex, which is a thin gray matter covering of the cerebrum. And this carries on our thinking and perceiving. And there are cerebral hemispheres. There are two walnut-shaped halves of the cerebrum, as you can see, kind of divided down the middle on this diagram. And as I think every single one of you, maybe one or two struggled a bit with it, but pointed out on the quiz, no, if you're right brain, left brain doesn't mean you only use that half of your brain. Kind of similarly to this, there's this myth that we only use 10% of our brain capacity. And that might be in a given moment true, but typically we're using all of our brain throughout a day, right? So there was a movie a couple years ago with Scarlett Johansson. It was she activated all of her brain and she got all these abilities, right? And that's not a thing. We are using our brain at 100% capacity. we are using both halves of our brain unless there's a serious injury on one side and we just can't use it anymore, right? And then we're going to be impaired in a lot of ways. So these diagrams are really good views of the 4 lobes of the cerebral cortex, and each of these lobes has a different function. And each hemisphere has all 4 lobes. So as you can see, it's like a mirror image across the center here, the central vision. So the occipital lobe back here, a little higher up than your brainstem. The occipital lobe is where the primary visual cortex is located. It does visual processing. Interesting sort of side note. Oh, it's Lucy. Thank you. Yes, Lucy was the name of the movie. Yeah, not good. We had fun making fun of it in our department, on our department Facebook page back then. So because of how your eyes process things, the optic nerves actually cross, and so the left part of your brain processes the right side of your vision, and the right part of your brain processes the left side of your vision. Just fun anecdote for you for today. Because of the placement of the occipital lobe back here, this is why if you fall and hit the back of your head, you might like see stars, right? Because you're having injury in that area. And this is also related to why people might like kind of lose vision for a minute if they get a head injury. And it doesn't have to be back here, the head injury. If you hit the front of your brain, or the front of your skull, the brain is kind of like jello, so it bounces around. So if you strike the front of your brain, often because of the bouncing, essentially the back part of your brain will also be affected. This is why you see that affected in, say, NFL players or other football players who get closed head injuries. Okay, the parietal lobes, sort of this part of your brain here. So those are where primary somatosensory cortex is located. So the parietal lobes do sensation. So sensation is our objective reality. And again, chapter 4, we're going to go into sensation and perception in a lot more detail. But essentially, this is like hot, right? This thing is hot. Perception is subjective psychological experience. So perception is objective, what's actually happening. And then perception is subjective psychological experience. Oh, that's hot and painful, right? Okay, so what areas do concussions affect the most? Good question. It kind of depends on where your head gets struck. But typically in contact sports, we tend to see it more in the frontal lobe and the occipital lobe. So the frontal lobe does things like help you sequence things, help you organize things, things along those lines. Ooh, and someone asked about synesthesia. I'm almost positive we have some material about synesthesia that we will end up covering on Wednesday. Let me double check. If not, I will tie some in because it's really cool. We might actually cover it in the sensation and perception chapters. But synesthesia, if you're not familiar, is a disorder where essentially one of the theories is that things kind of cross in your brain, and you end up basically like seeing colors for numbers or like smelling words, things along those lines. Really interesting disorder. Yes, we will cover that in chapter 4. I do have information and a video we'll watch for that. Really interesting stuff. Like if you listen to the people and you don't know they have synesthesia, like it just kind of sounds like they're on drugs. Like they're like, 5 is always red. And you're like, what? But it's actually the way that their brain is processing is very different than the rest of us. Very cool. Yes, we will definitely talk about that. Integration is where all the information comes together. So these are still things that your parietal lobe does. Your parietal lobe does a lot. So it senses things, it perceives them, gives you that subjective psychological experience. It integrates all the information, right? So if you think about having something as simple as, ooh, things are burning on the stove. I need to grab it. Oh, that's hot and painful. Oh, I see visually that now like the mac and cheese is everywhere, the noodles. All those things get integrated to process into one thing and give us the best way to react to it. It also does complex attention, helps us to pay attention, it stores information briefly. And then the parietal lobe also helps us with self-awareness. So we self-monitor and are kind of aware of what's happening for us. Okay, then the temporal lobe, this part right here, sort of right above your ear, is the temporal lobe. So this is where the primary auditory cortex is located, so where we really process sound. But it also does things like memory, maybe not surprisingly, since it's so tied to auditory, speech, right? Comprehension. It gives us our ability to lay down new memories and the ability to receive and process that information. And then again, it has the ability to output things in language. And then the frontal cortex, this part up here, okay? And this is really the part of us that's more developed in humans than a lot of other animals. It's where we have our primary motor cortex and what we call executive control. So kind of like the CEO of the brain, orders everything else around, make sure everything is working. So it does things like planning, sequencing. The frontal cortex is what lets you know, like, I should put my socks on before my shoes, right? Sounds relatively simple, but if you have frontal lobe damage, sometimes it actually does lead to some issues with things like that. Also judgment, social behavior, things along those lines, and even attention as well. So although they're, again, both hemispheres have the same lobes, there are sort of specialized areas within them. I think it's, actually you can kind of see that over here. So you can see there's an area labeled Broca's area over here. That's one of our areas to deal with language. So we have it in our left side, but not our right side. Okay, so it seems like the left hemisphere does more regulating positive emotions. The right hemisphere does more regulating of negative emotions. Left hemisphere is controlling muscles used in speech, again, because it's related to that speech center. Right hemisphere responds to simple commands. Left hemisphere is controlling sequence of movements. Right hemisphere is memory for shapes and music. Left hemisphere is, again, other language-related things, spontaneous speaking and writing, memory for words and numbers, understanding speech and writing. Right hemisphere does more of interpreting spatial relationships and visual images, recognition of faces. But the really interesting thing is if one of the hemispheres is more damaged than the other, we can actually sort of compensate with the other side. So one of the things we actually didn't really figure out till the 1990s, it's what's called plasticity in the brain. So the human brain is actually plastic, which means that it can adapt and change. We used to believe you were born with all the neural connections you were ever going to have, and so you were screwed if you had any kind of damage. And what we've discovered since then is we can actually sort of reroute our pathways in our brain. So for example, Representative Gabby Giffords from Arizona, who was shot through the left side of her brain, including all her speech centers were damaged, essentially. She was able to relearn to speak through singing, so essentially rerouting through the right side of her brain. So again, these are not completely fixed. Then you can have what's called split brain patients. So what will happen is there is one main connection between your two hemispheres, and it's called the corpus callosum. There's another small connection where the optic nerve crosses, but this is the main one of how the two hemispheres communicate with one another. If you have very, very severe seizures, they seem to be located to one side of your brain, there is a surgery they can do where they actually sever the corpus callosum to essentially localize it to one side of the brain. So this is the connection between the two hemispheres. And what happens then is what they call duality of consciousness. And a person can identify something with the left side of their brain maybe, but not the right. And again, this is where you end up having, difficulties because the left side of your brain communicates with the right side side of your brain communicates with the left side. And so here's an example of, this person has their corpus callosum split. They're asked to identify this, and it looks like it's basically a tennis ball, just by feeling it. They're not allowed to look at it. And what they find is this person can't identify it verbally on their right side because that's not where the language centers are, right? And so when they use their left hand, their right side of the brain's trying to process it, and it can't. But if they hold it on their right hand, their left side could say, oh, that's a ball. Now, really interesting thing is if you give the person a piece of paper while they are trying to hold the ball with their left hand, they can sometimes draw what they're holding, even though they can't verbally say what it is. So let me see if my hyperlink still works. And if so, I will reshare my screen here. Hey, it does. Okay, cool. I will reshare so that you are able to see this. This is a little video about that.
I know the left hemisphere and right hemisphere now are working independent of each other, but you don't notice it. Now, you just kind of adapt to it. You don't have any feeling different than it did before.
7 years ago, Joe had brain surgery to allay the effects of severe epilepsy. His surgeon cut the nerve fibers connecting his left hemisphere with his right. While the operation was a complete success, Joe's unusual case offers an extraordinary insight into the machinery of mind.
So it hasn't really made any...
This fiber system, the corpus callosum, is located midway between the two hemispheres. When it was surgically severed in Joe's brain, the transmission of information between the two hemispheres was halted. Michael Gazzaniga.
What we can do is play tricks by putting information into his disconnected, mute, non-talking right hemisphere and watch it produce behaviors. And out of that, we can really see that there is, in fact, a reason to believe that there's all kinds of complex processes going on outside of his conscious awareness of his left half brain. Joe, I'm going to show you some things. I just want you to tell me what you see. And here we go. You ready? Look right at the dot. Okay. Right. Okay, you ready? Look right at the dot. Grapes. Good. When Joe focuses on a point, look right at the dot. Everything to the right of the point goes to his left brain, the dominant hemisphere for language and speech. Look right at the dot. So we can see here that when we flash a word or a picture, Joe is easily able to name it. Here we go. See it. Close your eyes and let your left hand do a little work here. Okay, what do you got there?
Pan.
Okay, very good. Now, when a word or a picture falls to the left of a fixation point, that information goes to his disconnected right half brain. And as we can see here, Joe is unable to name it. Joe is able to draw the picture with his left hand, the left hand getting its major control from the right half brain. What'd you draw?
Okay.
What'd you see?
Wheel on one side. I don't know what I saw on the other.
So even though he can't name it, his left hand is able to draw out the picture of the stimulus of the picture or word that we presented to his right half brain. What did you see?
Saw a hammer.
So just close your eyes and draw with your left hand. Just let it go. Bryce, what's that?
Salt,
Yeah. What'd you see?
hammer.
What'd you draw that for?
I don't know.
What we have with Joe is just a dramatic example of a neurologic case that really allows you this window into the non-conscious and how powerful non-conscious processes are at influencing our conscious self, our personal self. What Joe and patients like him, and there are many of them, teaches us is that the mind is made up of a constellation of independent, semi-independent agents, and that these agents, these processes can carry on a vast number of activities outside of our conscious awareness. Even though that goes on, there's some final stage or some final system, which I happen to think is in the left hemisphere, that pulls all of this information together into a theory. It has to generate a theory to explain all of these independent elements. And so, and that theory becomes our particular theory of ourself and of the world.
All right. So that gives you a nice example of what it looks like when someone is dealing with these things. There we go. I am just making sure that I give all of you credit for being here today. But I wanted to see, well, we're going to stop a few minutes early. Wanted to see if anybody had any questions about what we just watched or any of the material we covered today. All right, if not, y'all can sign off early, and I will see you on Wednesday to finish this lecture and do our review Jeopardy!